Good morning, fellow programmers. Thanks for joining me. I'm T-Pain. And welcome to Let's Learn C++ Solutions. Make sure to have annotations turned on so you can see the updates I make to this video, and so you can jump to the section you are looking for. Solutions are what this episode is all about. I will not be explaining the debug challenges, as the solutions are at the bottom of each file. Now select an adventure to blindly dive headfirst into. Alright, so here we are in lesson 1. Let's go through the problems. The first one says, create a program that outputs, I'm going to be the best programmer in the world, in double quotes. And here I have it broken up into 3 individual lines. You could have combined this into a single long line, but I felt it was harder to read on screen. So I broke it up this way. And that's it for the first problem. It's just standard, C out, and the message we want to put. There we go. Just that simple. Oh yeah, and you need to make sure to have the include, main function, return, all that stuff. This is the default code that you need to run the program. And here's the second message. It says, create a program that outputs, hello, I am Ham, on one line. Then, hello, Ham, I am Sandwich. I love you. And then following that, print out, I love you too, Sandwich. All right. So pretty simple little program. This is just testing to make sure that you know how to output multiple lines. So here we have just that. Okay, nothing too complex yet. Next we have create a program that outputs changing return type, fingers crossed. Then change the return type for the main function from int to char. Instead of return 0, type return A in single quotes. Note to surround A with single quotes. And so what we do is we change the return type from int to char right here. And then we just return A like we said in our problem. And that's it. And if we run it, now this may just be in Visual Studio, this may not be for all platforms, it should compile just fine. So I'm going to go ahead and set an out point there, and indeed the program is executing just fine. So that is it for tutorial 1. Let's move on to tutorial 2. Here we are in exercise 1 for lesson 2. It says create 5 char, boolean, int, float, and double variables with different values. Okay, and we did just that. We created A, B, C, D, E, Booleans, and I just labeled these just B1, B2, B3 because that's much easier to create, and we just basically created them over and over again. So really simple. We didn't actually ask for them to be output, so we don't output them at all. All right, and that's it for this one. Exercise 2 says enter and output the following variables and see if you can figure out what it's doing. So we have an unsigned int, and then we're setting it to a value of -1. An unsigned meaning that the int itself cannot be negative. So setting its value to -1 will actually, if we run the program, and I'm going to set a breakpoint at the end, let's go ahead and run it, will actually create the highest value possible for each of these. So for a short int, it creates 65,535, and then much larger values for all the others. So if you have an unsigned int, this is the quickest way to get its max value, aside from actually using int max or uint max if you so desire. Okay, exercise 3 says enter the following code, and we did just that. And if we run it, we get an output of 1. What's going on here? So x is equal to 1, then y is equal to x. X is changing in value. So we're actually creating a copy of x's value to y. So its value does not get changed. It's only when we actually create reference variables that the values will change, because these are 2 different addresses in memory. So they will have unique values, and changing one does not change the other. And that's it. Next we have create a triangle with the following code. And here we just have that code. And if we output that, we will get a nice triangle made of these little stars. Beautiful. This is my definition of programming art. All right, and that's it for this program. Let's move on to the next exercise. And exercise 5 says, now create a square, diamond, an X, and an empty square. And here we have the code for each of those. So this one we just basically print out the same line over and over again. The next one we print out it's spaced out properly. Next one we actually print out the X. And the final one we actually print out a square. And if we actually run our code, we will see just those. We've got our square, our diamond, our X, and our hollow square. And that's it. Now let's move on to exercises for number 3. Exercise number 1 asks you to explain something. When would you use cin versus getLine? The answer is you'd use cin for a single variable, and you'd use getLine when the user is going to input any spaces into it. And that's it. Exercise 2 says output a math operation that uses plus, minus, times, divided by, parentheses, and a single modulo operator. All right, so number 2 says output a math operation that uses plus, minus, times, divided by, parentheses, and modulo. Now, I did not specify whether this should be in a single line or in separate lines, so I created one up here that uses all of those, and then I created them individually down here, and each of those work fine. So if I run it, it'll output the results of each of these. Okay, cool. Number 3 says create an output that uses is equal to, less than, greater than, less than or equal to, greater than or equal to in a single line. So I created that right here, which is 5 is equal to 4, or 5 is less than 4, or 5 is greater than 4, and so on and so forth. And just put all of those in a single line. And if we run that, it'll work just fine and close out the window way too quickly. And it'll just output 1 for true. Cool. Exercise 4 says create an output that uses ampersand and double vertical bar in a single line. And that's just what we did in our previous example, but this is just far more simple. So we do just that, put it out in a single line, and output it, and run it, and it should yield 1 as true. Done. Number 5 says ask the user to enter 3 integers within a single line, then store those 3 entries using cin. Okay, so we create ints a, b, and c, and then we're going to output the prompt, and then we're going to store the user's input in cin for a, b, and c. Something to note is that you're using the insertion operator with cout. You're going to use the extraction operator with cin. So that's double less than is for cout, and double greater than is for cin to store the input that the user is plugging in. So if you go ahead and run our program, we'll test it out real quick. And enter 1 space 2 space 3, enter, and we'll see that each of those is stored in memory successfully. Cool. Number 6 says ask the user to input an int, then output the values 1 greater than and 1 less than it by incrementing and decrementing. Okay, so first we have our prompt. We create our variable that we're going to be storing it in. Then we store the variable that the person is inputting. Then we store the value a that the user has input. And then we output a value greater than by putting the increment operator before it, so it outputs it after it has been incremented. Then we decrement and decrement again, and then output that second value. And so if we run it, say input an int, we'll put 100. It closes out and it flashed really quickly, but it showed that it was indeed working, that it was 99 and 101. So if we put 100 again, we'll see 101 and 99. Perfect. And now we'll move on to lesson number 4's exercises. All right, so here we are in lesson number 4's exercises. Number 1 says create an int array with min and max int values. So we just create an array right here, and then we just store int min and int max, and then we output each of those to make sure that everything works. And we'll go ahead and save that. Create a breakpoint for our program. And here we have our min and max values here. And my computer freaked out and minimized everything. Why, computer, why? So exercise number 2 says create a double array with 5 double values. Okay, so here we've created our double array right here by using the curly braces to enclose all 5 values, and then we output each of those to make sure that they're working. Let's go ahead and test it out. And indeed, each of those values are outputting successfully. Cool. Exercise number 3 says create an array of size 1, then set its value. So here we create a character array of size 1, and we set its first item equal to A, and then we output it, and everything's happy shiny. We're done. Exercise number 4 says create a 2D array of characters, assigning them values A through I. All right. So when dealing with 2D arrays, I'm going to be referring to this first array as the rows and the second array as the columns. So for the first row, we're going to set all these values in that first row with A, B, C, D, E. And then we're going to set the second row values by accessing the second row and then individually identifying these guys. And this was just a way to set the second row up with values. Another way that you could have done it is by setting them all at once. So you can do this by individually passing in two sets of values enclosed in curly braces to set them, or you can pass them all in at once. And based on the dimensions, they will autofill to their proper place. So the first row will have A through E, and the second row will have F through I. Very cool. So that is the quickest way to fill a two-dimensional or 3, 4, 5, 6, however many dimensional array that you have. You just have to multiply the sizes that you have together to find out the max number of letters you can include. I just included 9 here, however it could go up to 10. And then we're just outputting the second row and the fourth item in the column for each of these arrays. And we should get the same value for each. And indeed, we see I being output, so everything worked correctly. So this was a slightly trickier problem and required a little bit more research, but hey, now you know something new and cool. Exercise 5 asks us to create an int 3D array with assigned values of 1 through 8. So just as we discussed before, we're gonna have rows, columns, and depth. So just as before, we're gonna have rows and columns, but then we're gonna have a third dimension here for depth. And all those values can be assigned at once by enclosing all the values within the curly braces. And it will auto-assign each of those based on the row and column and depth that they belong. And here I will access the second row, second column, and second depth item, which should theoretically be 8. And when I run the program, indeed it does output 8. Perfect. Number 6 says create a character array with your name. So I did just that. I created a character array and output it to T-Pain, and then I output that. And when I run the program, surprise, it outputs T-Pain. Okay. Number 7 says create a character array with only special characters. All right, and we did just that by outputting the new line character, the tab character, the backslash character, backslash single quote, backslash double quote, and the backslash null character. And when we run that, it outputs this emptiness and weirdness. Hooray! Exercise 8 says create two strings called food1, food2 with values soup and salad and swap them. So here we have two variables food1 and food2 set to those variables. Then we call the function swap that is built into food1 and pass in food2 as the parameter, and then it will swap them for us. And that is it for tutorial number 4's exercises. Let's move on to tutorial number 5. All right, so here we have number 1, and this one was kind of a doozy, and I apologize for making it more difficult than it should have been. Number 1 says create 5 different variables of different data types and output each of their values and addresses. Now, if you tried to create character and print out its address, stuff would actually start going wrong there. We'll get into that in a bit. So here I have boolean b, character c, d for double, f for float, int I, and a string for s. So I created 6 instead of 5 just so you can see what char does, because that's the one that screws up your program. So first I try to output the address of c by passing the reference operator. The thing is that the extraction operator, when combined with the address of a character, interprets that as being a character array and will try to output everything following it, even though it's just an address of an individual character. It's one of those weird quirks that are built in this system. So the reference address of a single character is interpreted as a character array or string, and basically will continue until it hits a null character. So let's go ahead and run our program to see what I'm talking about. We scroll up, we'll see this large garbage value that's being output right here, and it's just a whole bunch of stuff until it hits that null character. Okay, so how do we get around this problem? What if we just want to output the address that that character is at? Well, there's 2 different ways. The first way is weird, and I haven't introduced this to you now. I will introduce it to you when we start getting into functions and classes, because there's where we're actually going to be using it. But there is this operation where you pass in a set of parentheses and then create a void pointer right here, or void star. And this command says, hey, give me the address of whatever I'm next to, no matter what. It's basically like some angry thug holding a gun up to the address and be like, I want your address no matter what. And also a side note is that void star is the way to get a pointer to any type of object. There's no type checking whatsoever. And it's the way that we're going to access this character's address. And so then we finally successfully get out the address where that character is being stored. Another way to do this in a safer way is going to be using static cast, but we're not going to get into that for a while. But for now, this is the way I would recommend doing it right now. Once you start becoming a professional, you'll understand that this is the proper way. So yeah, that's a way down the line thing. For now, know this method. And then I outputted a space, and then the addresses of everything else still works fine. And I wanted to show you right here with line 26 that if you just throw this void star next to anything that's already giving you an address, it doesn't freak out, doesn't do anything extra. It actually just continues to output the address as before. So adding it next to something that's not a char star or an array will output the same address as before. All right, and then we output the address of the float, the double, the int, and the string, and those all output correctly. Very cool. All right, so let's close out the program. Exercise 2 says create 5 different variables of different data types. Create 5 different pointers to those variables. Output each value they point to and the pointers themselves. So here we have the creation of 6 different variables. And again, this char is going to cause us problems. So then we have the pointers creating to each of those 6. And now I will show you the outputs of those by printing out first the pointer's value, then the address of the pointer, then the pointer itself, which is the address of the variable it's pointing to. Okay, and if we output that, we will see the following. Pointer 1 outputs everything just fine. Pointer 2 works just fine as well, except for when we try to print out pointer 2. It will try to output a string. So instead you must include the parentheses void star next to it so that it'll actually print out the address of that character. And then everything else is just pretty much what you'd expect. The addresses of hamstrings, doubles, everything. All works good. Exercise 3 says create 3 different variables of the same data type. Create 3 reference variables to the previous variables and store them in an array. Output the values in the array. So we're creating 3 variables here. Then we create 3 reference variables, A, B, and C. We store those within an int array. And then we output those variables right here. And 4, 5, 6 outputs correctly. Number 4, create a char variable and output its value using both ampersand and star in front of it. Okay, so we create a variable x, then we output its value using the ampersand and then the pointer to it. So this says, hey, give me the address. Actually, just give me the value. And if we output it, it'll output just 5. Perfect. Number 5 says create a 1int array. Output the value within it using both the brackets index 0 and the star methods. So we have an array of size 1 with a value of 4 in it. Then we output the value 4 by accessing the first item in the array. And then we also just use the value at star right here and get the value at this address. And they'll both output 4 just like we'd expect. Perfect. Number 6 says create a 5-item array. Output each of the addresses of the items by adding ints to the original array variable. Okay, so here is our creation of the 5-item array. And then we access each of the items using the star method. And then adding 1, 2, and 3, 4 gets us the value at 1 item, 2 item, 3 item, and 4 items down from the first initial item. And gets us each of those values. Perfect. And if we output it, it'll count out 1, 2, 3, 4, and 5. Number 7 says create a pointer that points to an array of 5 ints. Then output to see the current value it's pointing to using cout and star. Then on the next line, use the increment operator on the pointer. Finally, output its value again. Okay, so we've created an array here. Then we're creating a pointer to that array that's set to the exact same value as the array. And then we're going to output the value at it and then increment after we're done with this single line of code. We're going to increment the value of the pointer. And after that, we're going to output its value again. So this was a very slim way to do it. We could have split this up into separate lines if we so desired. I just want to make it easy on myself. And so we see number 1 and number 2 being output correctly. Cool. Number 8 says create a pointer that points to the last item in a 5-int array. Output the value at its address, then use the decrement operator ---- to go up the array by 1 item. Finally, output the value at the pointer's new address. So we have a creation of an array. We're going to set it equal to the last item of the array by just saying give us the position of 4 items down from where it's at initially. Then we're going to use the decrement operator before the line of code executes to decrease its value and print out the 4th item in the array, which should be 4. Let's go ahead and test that out. And indeed, we have 4 being output. Cool. So here we are in the solutions for lesson number 6, if, else, and switches. Number 1 says create 3 if statements with 1 true and false as the arguments, but do nothing. Okay, and here we have just that. Just if 1, if true, if false, and then using the semicolons as a don't do anything statement. Okay. Number 2 says create 3 if else if statements that check an int to see if it's less than, equal to, or greater than 0. Then output each as a statement of 5 is greater than 0. So here we have 5 is greater than 0, 5 is equal to 0, 5 is less than 0, and we output each of those based on what it is. If we run it, we'll solve the mystery of if 5 is greater than 0. Oh my god! Number 3 says create an if-else statement that checks if a variable is odd or even, and output just that along with lots of other random days of the week in the block of code using curly braces. Why I added that second part in, I don't know. All right, so here we have our code. It just says 5% 2, and that's true, so it says 5% 2 is odd, and Wednesday, Friday, and Monday. That's it. You doing okay in there, babe? Yeah. Okay. Number 4 says create a conditional operator that checks if a number is odd and then outputs just that. So here we have 5% 2 question mark cout odd or cout even, separated by a single colon. And if we run that, we'll find out 5% 2 is actually odd. It's 1. Oh my gosh. Number 5 says create a conditional operator that checks if a number is positive and returns ham or toast, which is stored in a string variable. So we have a string variable s here created, and it's equal to whatever the output of this conditional operator is. So is 5 greater than 0? Question mark. Ham or toast? And let's see what the results are. It's killing me. Don't know what it is. It's ham. Oh my gosh. 5 is greater than 0. Yay. Number 6 says create a conditional operator that checks if one variable is greater than the other and outputs which variable is greater. So then we have the creation of x and y here. And is x greater than y? I don't know. Cout x or cout y. Turns out x, 4, is greater than -2. Who would have guessed? Oh, it's so crazy. Number 7 says create a switch statement that has 3 different char cases and outputs which letter it is. Do not include breaks. So here we have our switch statement. We pass in a character A, and then we have case B, case A, and case C, and then outputting each of those. And if we run it, we'll get case A and case C because there is no actual breaks. There is no inlines either. So that's it. Number 8 says repeat number 7 above but use numbers, include breaks, and add a default. So here we have our switch statement. We pass in 1, and we check cases 1, 0, 1, and 2. And then we have the outputs, and we have breaks separating out each of these cases, and a default added to the bottom that outputs unknown. And indeed, 1 is satisfying case 1 and outputs 1. Surprise! And that is it for lesson number 6 exercises. So now we're moving on to lesson 7's exercises, the for while loop section. Number 1 says create a loop that prints out 0 through 10. Okay, so here is our for loop. We start at 0, we go up to and including 10. And if we output that, then indeed we get all of those, 0 through 10. Perfect. Number 2 says create a for loop that prints out 0 to 100, but only even numbers. Here's where things get interesting. We're going to start at 0, we're going to go up to and including 100, but now instead of incrementing by 1, we're going to increment by 2 by using the plus equals 2. And if we output that, we get counting from 0, 2, 4, 6 all the way up to 98 and 100. Perfect. Number 3 says create a for loop that prints out 0 to 100, but only odd numbers. Now when asking for this, I know I realized I should have started at 1 to 99, but that was to throw some people off because they're thinking about 0 to 100, but what you should be thinking about is 1 to 99. So we're going to start at 1. So all we had to do is copy the last exercise we did and then just change the initialized value from 0 to 1, and everything else would be done for us. So now we will get all odd numbers when we run this. So go 1, 3, 5 all the way up to 97, 99. Perfect. Exercise 4 says create a while loop that outputs a character array with one less character every time it loops until it holds only null values within it. So we have our character array set up right here equal to ham sandwich. Then we go and check to make sure that it has a length inside. And every time we set one of the values within it to null, it slowly shrinks in size, even though it's not technically changing in size. And then we output that value. So if we go ahead and run the program, we start out with ham sandwich, and then go down to ham sandwich, and so on and so forth until no letters remain in that array. And that's it. Number 5 says create a do while loop that only executes once. All right, so then you just create a do with a simple statement, ham sandwich, and then the while loop is set to false, and it runs just fine. Only outputs once. Perfect. Number 6 says create a nested for loop within another that prints out the product of each iterator ranging from 0 to 10, creating a times table of 0 to 100. Hence, use printf with %0.3d and pass in this value for the output with proper spacing between them, instead of cout times of I times j or whatever. Okay? And this was pretty tricky. This is the equivalent of, this statement right here is the equivalent of what we would actually use in Python to output some zeros in front of integer values that are smaller than 100. We would say in double or single quotes, didn't really matter, %0.3d, and then have % follow it, and I times j following that. And that could be optionally enclosed in parentheses if we had multiple arguments that we were passing into the string or substituting into the string. But this is C++, so how do we do it this way? Instead, we're going to use printf, which I have not introduced you to just yet. But printf is another way of outputting, just like cout. The only difference is that it's specifically designed for outputting this in this way, for controlling how much text is being output. Or if you're converting integers, decimal points, how many of those characters are actually going to be output. That's all. So we have a for loop right here with I as a value, going from 0 to 10, and then we have the same thing going from 0 to 10 with j, and then we just output what's being multiplied, and then finally have a indel between every iteration of the loop so that we can break up our times table. Now if we run it, we'll get this output, and I'll stretch this out so it actually turns into a times table. So we have 0, 1, and then it counts all the way here as if this was 0, and the 1 for the column. If we go to 3 times 3, then we'd go here. That would be 9, and so on and so forth. So you could do 4 times 4 is actually 16, 10 times 10 is 100. So this is just a basic times table. Very cool. So that is it. Thank you guys so much for watching, and great job keeping up. Please leave me a comment below if this helped you at all, and check out the comments if you're having any problems. Lastly, please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Hit that like button to show some love, and support me on Patreon by clicking that little tiny button in the top right. Thanks so much for your support, and keep the dream alive.